Yeah, welcome once again to another section of functions. In the previous classes, we'll be discussing of what's function, mapping in the function, and we did a couple examples of the types of functions, the one-to-one, the onto function, the subjective and the injective functions, and we did a very detailed explanation. In case maybe you miss out the section of the functions that we've discussed before, you can go through our channel, Explicit Physics Academic, and then you scroll down, you will see the different sections of functions we've had. We've had life sections and so on and so forth. So we've talked about function as function is a relationship between two variables whereby one is depending on the other one, and we've talked about the domain and the range. So in this class today, we'll be looking at what's composite function, how to put, what happens when you put one function into another function, what happens, what's the end result, how do you do it. So we'll be discussing on composite functions, we'll be discussing on how to evaluate composite functions. We'll solve a couple examples at least, and then thereafter we're now going to common mistakes students make in composite functions. Okay, let's dive in. So what is a composite function? A composite function is a function that takes another function as its input, denoted as f on g of x, which is equal to f into g of x. So function is an equation that takes a function as its input. So it's like, as I'm standing here, I'm taking this material sheet I'm using to lecture as my input. So that's composite function. It's a combination of two functions to produce a new function. A combination of two functions to produce a new other function. So you can see that it comprises of two functions, where f is the outer function and g is the inner function. So that's what composite function is all about. It's just two functions coming together to produce a new function. So when you go through our last class, we talk about different rules in composite function. When we have the sum rule, we have the product rule, we have the quotient rule, and we have the difference rule. So all this all embodies and help us to solve functions. Okay, so we are going to be entering into how to evaluate functions. I believe you've gotten a little idea of what composite function is all about, and what happens when you put a function into another function. That's composite function. It's very simple. So let us look at how to evaluate composite functions. How to evaluate composite functions. Before we move on, you should know that this video is very, very beneficial to high school students. It's also beneficial to college and university students, and also for JAM students, for WAEC students, for NECO students, for SAT students, and anyone who loves mathematics and want to take math as a subject on his own. So you should know that this video is very, very helpful. So let us dive in on how to evaluate composite function. This is going to be very mind-blowing. Now, identify the function. That's the first thing. There are 4 basic steps. And you should know that in math or physics, anytime you're solving a problem, there are steps that should be followed in solving any problem that is given. So the first one is identify the function. So when you are given two functions and you are asked to find f of g or g of f interchangeably, what you have to know first is to identify the function. What is the degree of that function? What's the function looking like? Is that an exponential function? Is it a trigonometric function, or so on and so forth? Identify it first before you dive into solving it. And then identify the two functions involved in the composition, f of x and g of x. That's very, very important. The second part is determine the order. You determine the order of the function. Are they asking you to find f of g, or is the question saying you should find g of f? You should pay attention to that. Mostly you will see questions that are being asked to find f of g, but pay attention to it. It may be telling you to find g of x. Meanwhile, you have in mind that, of course, it's a simple question. I've solved something like this before, and it's going to be g of x. So let me just dive in and solving it. And by so doing, you get it all wrong. So you should understand that anytime you're given a problem on composite function or two functions for you to find, maybe using the sum rule, using the product rule, or using the difference rule, the quotient rule, what you have to know is to identify the function first, and secondly is to determine the order of the equation, and they ask you to find the f of g of the g of x. And the third one is to determine g of x into f of x. This is the main part to evaluate. How do you evaluate? When you find x, you carry where g is, the equation of g, and put inside it. We are going to be solving it very, very soon. But let us understand this step detailedly before we dive into it, so that from this knowledge, it will propel us to solving it very adequately. Alright? So the last one is simplify the expression. That's very simple. So the basic three, the first step we have is determine the function, determine the order, substitute g of x into f of x, or inversely. Then the last one is simplify the expression, the result, the final result. They may ask you to find f of g or g of x when x is 2, when x is 3, when x is 0, and so on and so forth. So we're going to be taking a couple examples, and maybe 5 or 6 examples, so that it will create more ambience and more understanding of what composite function is all about. The first question, let's just solve it here. So we write our solution here on the board. I'm using shorthand. So the first one says if f of x is 2x plus 1 and g of x is x squared, find f of g of x. F of g of x. So this is how you solve it. F of x is equal to 2x plus 1 and g of x is equal to x squared. So how do we solve this? We are going to be solving it. They say we should find f of g, this equation 1, all of x will now be equal to f of g of x. So how do we put it all together? This is how we're going to be solving it. We are going to put where x is, right, 2. This is the equation of x. So when you find x, you put this guy, because it's a function of x. Anywhere you see x, you substitute in the value of g of x, whatever is in g of x. So we have 2. Here we're going to have g of x, okay, plus 1. Here is a constant, and it's not a function of x. It's not related to x. So take note of that. So f of g of x will now be equal to 2 into x squared plus 1. And now this will give us 2x squared plus 1. That's it. Very, very simple, very plain. Let's look at the second one. The second one says we are given f of x as x cubed and g of x as 2x minus 1. We should find x squared plus 2 and g of x is x minus 1. Find f of g of x. So I'm going to be solving it here and see how I can minimize this space so that everything will enter in accordingly. So we're going to be having from that f of x of x will be equal to, we have this, so we write we're going to be writing g of x plus 2. That's putting it inside into this equation. So when we solve it together, what we're going to be having is to have, putting this guy into here, we're going to be having x plus 1 all squared plus 2. So when you now, of course, if you wish to, to spread it, you can spread it and get the solution, but I prefer to leave it at this point. Please note what we are doing. We are asked to find f of g. So how to find f of g is to take anywhere you see x in the first outer equation, you put in what is here into this. If you put this into this, you're going to be having x minus 1 all squared plus 2. That's what we have here. So let's solve the fourth one. So the question 3, the third work example. So we're given f of x as equal to x cubed and g of x as equal to 2x minus 1. We have to find f of g. So f of g, all of x will be equal to 2x minus 1 all cube. Spread it, can spread it, but I wish to keep it like this because you have to find f of g. So this becomes the solution. Just when you find s, carry g and put it inside. Okay, so let's solve for the last one. We shall first say if f of x is 2x plus 1 and g of x is x squared plus 1, find f over g of x at x equal to 2. This looks a little bit tricky, but it's very simple. So we have f over g of x now be equal to 2x plus 1 all over x plus 1 all squared. Very simple. Or you can say, just let me clean this up and break it down. So you can say put f of x all over g of x, which is equal to 2x plus 1 all over x squared plus 1. Now the equation says at x equal to 2, what becomes the equation? So at x equal to 2, f of x will be equal to 2 times 2 into x plus 1 all over 2 squared plus 1. Here will give us 4 plus 1 all over 4 plus 1. And we're going to be having 5 all over 5, which is equal to 1. So f over g of x is equal to 1 at x equal to 2. So when you check carefully, you will see the systematic way I use in solving them. They are very simple, very plain, and very straightforward. So look carefully at it, how you solve them. You take in what is in g, put it inside of x, where you find x, and you solve it systematically. So let us dive into a different equation entirely and see how we can solve it interchangeably. So the first question here, let's draw the line again. So we just solve it down here. Okay? So I write my solution. Okay? So if f of x is x plus 1 and g of x is x cubed, determine g of f of x at x equal to 1. Okay, so we're going to be solving it here. You have that f of x is equal to x plus 1 and g of x is equal to x cubed. So we are asked to find g of f of x, which will be equal to g. Remember, in our way of how to evaluate, we use parentheses very, very well, very important. So this is what we are asked to find. So what that means is that this will give us x plus 1 all cube. Okay, then the question now says at x equal to 1. So at x equal to 1, g of x will be equal to 1 plus 1 all cube, which is equal to 8. Very simple. I believe that is well simple and well explained. So we go to the next one. Question 6 says, let f of x be equal to 2x minus 1 and g of x be equal to x squared minus 4. Find g of f of x and evaluate it at x equal to 0. That's the sixth question we are solving today. So we have that. We have to find our f of x here is equal to 2x minus 1 and g of x is equal to x squared minus 4. Okay, so the question is telling us we should find f of g and evaluate it as x equal to 0. So we are going to be solving that by doing this. Very simple. So g of x of f of x will be equal to g of f of x, which is equal to 2x minus 1 all squared minus 4. I believe that is well, very, 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 very clear and evaluatory. So let us move on. Let's project. So from here, if you now put x equal to 0, at x equal to 0, we are going to be having g of x will now be equal to 2, 0 into 0, that's 0 minus 1 all squared minus 4. So here it becomes 0, and we are going to be having 1 minus 4. And when you play with that, you are going to be having your answer as minus 3. So g of x is minus 3. So let us solve the rest of the equation. So we are given that question 6. Rather, okay, you try this out. Let's see what you get. So what's your answer? Okay, I believe you got something. Okay, so let's try it. So we are given that, that's question 7. F of x is equal to 2 power x and g of x is equal to x plus 1. So our f of g of x will be equal to, we're going to be writing f g of x, and this is going to equate us to having 2 into x plus 1. Very simple. That's it. So question 8, we have that f of x is equal to x squared plus 1 and g of x is equal to 2x minus 1. So g of f of x will be equal to g f of x, which we are going to be having 2 into x squared minus, so plus 1 minus 1. And if you do this all together, we are going to be having g of f of x will give us 2x squared plus 1. Because if you multiply 2 times 1 will give us 2. So that 2 minus 1 will give us 1. So here becomes your answer. So question 9, which becomes the last question in today's solving of solving our composite functions. We have it that f of x is equal to exponential x and g of x is equal to 2x, and the equation says we should find f of g of x, which we are going to be having as f g of x, and this will give us e raised to the power of 2x. So f of g of x is equal to exponential 2x. Very simple. I believe the equations that have been solved here have already covered the basics that you need to understand on composite function. Now, before we summarize the common mistakes students make when solving composite functions. The mistake that students make when solving composite function is forgetting to substitute the entire function. For instance, you are given this and you are asked to find g of x, and you forget to substitute in g, so equation to put in this into this. That's the common mistake. Neglect it if you don't really get the basics. And how do you avoid this? The first way to avoid it is to double check your substitution. So after solving, you have to put an eye on it, into it again carefully. If you use the other way, now check the first 4 examples we gave. It was g of x, and this question 5 it was f of g. Now for this question 5 we use g of x. So if now you still have that mindset that all the equation is f of g, and of course you've been solving it, you will now realize that after solving it and submitting it, if it's an exam, you see that you've messed it up. Not because you don't know it, but because you didn't check it. It's common mistake. These are common things that you can avoid it if you pay attention to it. So number one way to avoid it is to double check your work, double check your substitution, what you did after solving. And then the second way of which you can avoid that mistake is to use parentheses. This is what I mean. Parentheses. This will help you to solve your problem very, very well without mistake. So I believe we've been able to come to the end of this composite function class, and if you find this video very, very useful, please do well to share to your friends, and don't forget to click the like button, subscribe, and drop in the comment section what you think we should take next in our next video.